Hi, this is Ms. Park, and this video is on exponents and exponent laws. So let's first review what are exponents. So exponents are just a shortcut to show repeated multiplication. So for example, if I write 2 times 2 times 2 times 2, I can write that with a short form of 2 to the exponent 4. Okay, repeated multiplication. And I can figure out how much that is. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So 2 to the exponent 4 is 16. Okay, and so this expression 2 to the exponent 4 has parts to it. Okay, the 2 is called the base. The 4 is called the exponent. And the whole thing, a base with an exponent, is called a power. So it's actually not correct to say 2 to the power 4. I know we say it. A lot of people say it, but it's actually not correct. 2 to the power 4 doesn't really make sense. It's 2 to the exponent 4. Or we can say 2 to the 4. And the whole thing is called a power. Okay, so let's look at some patterns with exponents. So let's take, for example, base of 10, just because 10 is easy to work with. So 10 to the exponent 4 is 10 times 10 times 10 times 10. And when the numbers are simple, like 2 and 10, we could do this without a calculator in our head. So 10 times 10 is 100, times another 10 is 1,000, times another 10 is 10,000. Okay, and now I'm going to reduce the exponent to a 3. So this is 10 to the exponent 3, and that would be 10 times 10 times 10, which is 1,000, right? 10 times 10 is 100, times another 10 is 1,000. I'm going to reduce the exponent again. Okay, and that's going to be 10 times 10, which is 100. Notice every time I'm reducing the exponent, I'm multiplying by one less 10, right? And if I look at just the answers, these numbers over here, to get from 10,000 to 1,000, you divide by 10. That should make sense since we're including one less 10 in the multiplication. So to get from 10,000 to 1,000, you divide by 10. To get from 1,000 to 100, we divide by 10. Let's keep going. I'm doing this for a reason. Hang on. You'll see. 10 to the exponent 1 is just 1/10, so that's 10. And again, to get from 100 to 10, you divide by 10. This brings us to a new concept that we haven't seen before. What is 10 to the exponent 0? Okay, 10 to the exponent 0. We haven't seen exponent 0 before. So if I take my calculator and I go 10, and I use my exponent button, which for my calculator is this one here, the little caret, and I put a 0, and I hit enter, I get 1. 10 to the exponent 0 is 1. And the reason that is because if you follow the pattern, from every step to the next, you're dividing by 10. So if you follow the pattern, 10 divided by 10 is 1. All right, so this is an important line for us. So I'm just going to put like an arrow here. Okay, and I'm going to go 0 exponent. So we're going to talk about 0 exponent in a second. Okay, so that's important. That's new for us. The other thing is new for us is negative exponents. We've never seen them before. So if I continue this pattern and go 10 to the exponent negative 1, what should this be? Right? Well, if I follow this pattern, I should divide by 10. So how much is 1 divided by 10? Well, that's the fraction 1/10, which if you put in your calculator, 1 divided by 10, you get 0.1. All right, and so that's the meaning of negative exponent. Let's do another negative exponent, negative 2. 10 to the negative 2 is going to be 1/10 divided by another 10, which is 1 divided by 100. And if you put it into the exponent, into the calculator, it's 0.01. So again, what's the pattern? Dividing by 10. And if I divide by 10 again, I'm going to get 1 divided by 1,000, running out of room, which is 0.001. Okay, again, the pattern is divide by 10 each time. So following this pattern, we now understand what happens with negative exponents as well. Okay, so making some notes and put this all together. So 0 exponent, using that pattern. So any base raised to the exponent 0 will equal 1. Okay, so for example, 2 to the 0 equals 1. 5 to the 0 equals 1. 1/3 to the 0 equals 1. Anything I do equals 1. And even with variables, if I had variables x to the 0, doesn't matter what x is, that equals 1. Okay, so that's the 0 exponent. And the negative exponent, so the negative exponent, so a negative exponent will result in the reciprocal with the positive exponent. So watch what this is. I'm going to explain. So for example, 2 to the exponent -1 is the reciprocal. Remember, reciprocal is flipping the fraction. And this is 2 is 2 over 1. So flipping that fraction is 1 over 2 with the positive exponent. Okay, let's do another one. 4 to the -3 is flipping the fraction with the positive exponent. Like that, okay? Do one more. 10 to the -4 is 1 over 10 to the +4. It's the reciprocal with the positive exponent, right? So that's 0 and that's negative. The last thing we'll do is we'll talk about exponent laws. Okay, so exponent laws, we have 3. The first one is multiplying powers with the same base. So that means if I have, so let's do an example. If I have 2 cubed times 2 to the exponent 5, then that's going to be, if I expand it, that's 2 times 2 times 2 for the cube times 2 times 2 times 2 times 2 times 2 for the 2 to the exponent 5, right? 2 to the exponent 3 times 2 to the exponent 5. And how many 2's do I have altogether? 1, 2, 3, 4, 5, 6, 7, 8. So that's equal to 2 to the exponent 8. So the rule is when you multiply powers with the same base, add the exponents. Okay, 2 to the 3 times 2 to the 5 is equal to 2 to the 8. You add the exponents because when you expand them out, there's going to be 8 of these 2's. Okay, the next one, dividing powers with the same base. Notice that they have to have the same base. They both have to be 2's or 3's or whatever with the same base. So let's do an example. 3 to the exponent 10 divided by 3 to the exponent 6. All right, so that's going to be the same as 3 times 3 times 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, divided by 3 times 3 times 3 times 3 times 3 times 3, 6 of them. And what ends up happening is each of these 3's in the numerator will cancel out with a 3 in the denominator, like dividing top and bottom both by 3. So that 3 cancels with this 3, and this one goes with this one, and this one goes with this one. They just cancel away. And that one goes with that one, and that one goes with that one, and that one goes with that one. And we're left with 3 to the exponent 4. Because it's 3 times 3 times 3 times 3, that's all that's left. So look what happened. When we're dividing, 3 to the 10 divided by 3 to the 6, all of the 6 of the 3's go away, and we're left with just 4. So what's the rule? Subtract the exponents. Okay, and there's one last rule, and that will be the end. Okay, and this is going to be raising a power to another exponent. Okay, so let's go, for example, 4 to the exponent 2 to the exponent 3. I have a power, 4 to the exponent 2, and the whole thing is raised to the exponent 3. So what does this look like? This looks like 4 to the exponent 2 3 times. So cube means 3 times. So there's 3 of these. All right, but now each of these can be written as 4 times 4, right? 4 squared is 4 times 4, times 4 times 4, times 4 times 4. So how many 4's do I have? I have 2 here, 2 here, and 2 here, so I have 6 4's. Okay, and so that means if I have the base is 4, it's raised to a 2, and the whole thing is raised to a 3. How do I get 6? Multiply the exponents. Okay, so yeah, multiply the exponents. So that's it. So we have the exponent laws. There are 3. So actually, you know what? Let's number them. So 1, 2. So the first one is when you multiply powers of the same base, multiplying. Second one is dividing. And the third one is raising a power to another exponent. Okay, let's do quick example. Quick example that uses lots of things. Okay, so let's say 5 to the exponent 3 times 5 to the exponent 4 divided by 5 to the exponent 5. All right, so that's going to be, we don't have to put this in the calculator. 5 to the exponent 3 is 125, and 5 to the exponent 4 is 625. Well, we're not going to use those big numbers. We're just going to use the exponent laws. So 5 to the exponent 3 times 5 to the exponent 4, that's multiplying powers with the same base. So you find the rule. Multiplying powers of the same base, you add the exponents. So this is 5 to the exponent 7 over 5 to the exponent 5. And now we have a division with the same base. Okay, so now that's going to be 5. The base stays the same, and we subtract the exponents. So that's going to be 5 to the exponent 2. And 5 to the exponent 2 we can do in our head. That's 5 times 5, which is just 25. Okay, and the last one. Let's go 5, well, let's pick a different number. 6 to the exponent 3. The whole thing squared divided by 6 to the exponent 5. Okay, actually, let's change it. Let's make the 6 to the exponent 15. Make it difficult. Okay, 6 to the exponent 15. So this is going to be 6 to cubed times 6 cubed, right? Because the whole thing is squared. And that's going to be multiplying the exponents. So 3 times 2 is 6. That's 6 to the exponent 6 divided by 6 to the exponent 15. Division says that you should subtract the exponent, so that 6 minus 15 is negative 9. But what is the meaning of a negative exponent? It means that it's going to be the reciprocal with the positive exponent. So I'm going to put a note here. Always write with a positive exponent. So whenever you see a negative exponent at the end of your answer, we have to convert this to a positive exponent. So 6 to the negative 9 is the reciprocal of 6 with the positive 9. Okay, and that's pretty much your exponent laws. So lots and lots of practice for this. All right, so please do it. Thanks for watching.